Welcome students. In this session, we will be discussing about foundations of modern cryptography. Here, we discuss about information theory, perfect secrecy, and product crypto system. So, information theory deals with concepts related to transmission of messages through communication system. It studies the quantification, storage, and communication of information. The classical paper published in 1948, known as a mathematical theory of communication, Claude Shannon, who is father of information theory, introduces the concept of information theory, which forms the basis for modern cryptography and the modern communication systems. So there are various concepts discussed under information theory. Uh, First and foremost is the representation of communication system or formal architecture of communication system. It deals about what are the components present in a communication system. The next concept is digital representation of the information. So information can be anything. Can be a text message, or it can be audio message, video message, or image. All the message or all the information is represented as zeros and ones. That is binary digits. The next concept is entropy. Entropy conveys the amount of uncertainty in a random variable outcome. Information theory also discusses about channel capacity, that is the speed limit of a communication channel, and it also discusses about the noisy channel coding theorem, and then it also discusses about data compression. Here we focus on how efficiently we can represent a message and information with lesser number of bits. So as already discussed, entropy expresses the amount of uncertainty in a random variable outcome. It is given by a probability function. When an event is more uncertain, then it means that that event has higher entropy. Therefore, a message with higher entropy requires more number of bits to represent. Similarly, a message with lower entropy requires only a lesser number of bits. That is, a message with certainty will need only lesser number of bits to represent. Then we will be discussing about the concept of unconditionally secure cipher. So it means that uh, if the attacker who is going to break this cipher, if he has unlimited computing resources and unlimited time, still he could not able to break this cipher. Such a cipher is known as unconditionally secure cipher. Example is one-time pad. That is the only cipher which is unconditionally secure cipher, but it is not practically possible. We will discuss it later. And there is another concept known as perfect secrecy. It means that if you have, say, a message M0 and M1, both messages are equally likely to produce the same ciphertext C. So that is the probability of producing C for both M0 and M1 is same. So it means that the ciphertests are independent of plain tests. So the ciphertests are not dependent upon the plain tests, and that mapping depends upon the unique key, and it also requires that the key should be as large as plain text. That is, the size of the key should be as large as the plain text. And perfect secrecy ensures unconditional secure cipher. But the problem is, it is very difficult to get the key size as large as the message. It is practically not possible. So that is the problem with unconditionally secured cipher. That is one-time pack. that is generating keys often and distributing the keys. These are the problem with this one-time cipher. That is the only known unconditionally secure cipher. But instead of unconditionally secure cipher, we can focus on computationally secure cipher. Here, it has to satisfy either one of the conditions. That is, the cost of breaking the cipher should exceed the value of the encrypted information, or the time required to break the cipher exceeds the useful lifetime of the information. This can be a reasonable security requirement for modern crypto systems. Shannon also introduces the concept known as confusion and diffusion. Uh, so, if you have observed all the classical cryptographic algorithms, the problem with all the classical cryptographic algorithm is the statistics of the plain text is being reflected in the cipher test. Using frequency analysis, those statistics or those pattern is observed or found out. So that is the problem with all the classical cryptographic algorithms. That is Caesar cipher or monoalphabetic cipher or regional cipher, whatever it might be. All the cipher has this problem. The pattern found in plain text is being reflected in cipher test. To avoid that, statistical frequency analysis, Shannon introduced two concepts. One is diffusion, another one is confusion. Diffusion means the relationship between plain text and cipher text is as complex as possible. That is, statistics or the pattern found in plain text is not reflected in the cipher test. That is known as diffusion. Diffusion is achieved by using a complex permutation function. And then confusion. Confusion, it means that the relationship between the key and cipher text is as complex as possible. That is, we can't find the pattern of key in the cipher test. So confusion is achieved by using complex substitution algorithm. So using this concept of diffusion and confusion, we can avoid statistical analysis. As discussed, diffusion is achieved by permutation and confusion is achieved by complex substitution algorithm. And then there is a concept known as product crypto system. Instead of using a single cipher, we can use multiple cipher. The idea behind this product crypto system is if we use multiple cipher, then the cryptographic strength increases. That is the main concept behind product crypto system. It can be, for example, two substitution ciphers or one substitution cipher and one permutation cipher at least. It can have any number of ciphers. So these are the references. Thank you. With this, I conclude this session.